Hello, everybody. Thanks for listening to this talk about extending software systems while keeping conceptual integrity. It's a work I've been doing in Israeli, the Jerusalem College of Engineering, and was part of the SECE conference this July 17. I'll talk about the subject of conceptual integration. Then I'll move on to suggest a general model for software development lifecycle, which we will use further for investigating the conceptual integration of a case study. We'll talk about how to extend software systems and preserve conceptual integration, and then we'll move to the main issue of presenting the case study. We'll examine a popular service for project management called GitLab for its conceptual integration. And hopefully show a fruitful discussion at the end. Since this is pre-recorded, I ask you to send me an email, and if you have any comments, I'll be glad to continue the discussion. Again, the email is over here at the first slide. Okay, so let's start. Conceptual integration is a concept first discussed by Brooks in several publications. It talks about it has three major parts. When we talk about the conceptual integration of some software system, about the orthogonality of concepts, their propriety and generality. We will further examine this. In more recent years, there was a nice and interesting and influencing work by Jackson at MIT, where he used this concept to evaluate the design of Git. Git is a very popular version control system, started by Linus Torvalds of Linux fame, and is also known to have some issues. Many of them were dealt over the years, since it is a successful open source project. But still, there are issues we will not discuss there. I refer you to Jackson's paper. Anyhow, they came out with a suggested corrected design called Gitless design, and also an implementation. I'm not aware of its adoption, but it's very interesting as a design exercise. I here took a general process for software project lifecycle in order that we can use it later to examine if a service that would like to give tools and services for managing project management has a good conceptual integrity. So this is very general. Software project starts with some inception phase where requirements are started to be gathered, even maybe before that, some vision for the project and the business case and stakeholder analysis, things like that. And then usually projects go into development, what was historically called development, where actual code is being written, but today it is most common to be done in an iterative form, where the software is not built in one phase, but are gradually being evolved and built over time. And then most systems go into maintenance mode, where the system is in use, But as usually is happening with software, bugs are found, a new feature are being brought, so the system keeps evolving. Actually, in many projects today, there is no fixed line between the evolution phase and the maintenance phase. And then every system, or almost every system, phasing out. Sometimes user start using and degrade for various reasons. This is the end of life of the system, and nobody uses it. So our main issue here, how can we extend such systems which are being evolved and maintained in an iterative way while not corrupting its main design concepts? So first of all, we begin by giving the main features we would like such a service as examined here to have. So, of course, the main issue is having a version control, like Git. We would like to version our various outputs or artifacts of a project. Mainly code, but not only, of course, tests and other documents. We would like to have a useful and good documentation system. In many projects today, they find that the wiki form is the one that most suits the need of such projects. Next in importance is an issue database like Jira or GitHub issues, where we can manage the project according to bugs and general tasks. Okay. Usually a software project is a group effort, and we need some tooling to organize and cooperate, especially if the group is not located together. And no one service can give all needed services. So usually those services integrate with other services to bring other completing services. A notable example is continuous integration, where we would like that for every new version or commit, there will be an automatic process that will check that this process is, that the new change is compatible in many levels. Let's start with that it still compiles, the test runs, and maybe even in the future when we'll have tooling for examining the conceptual design, we can integrate it also. So specifically about software project management services, what are the challenges to preserve their conceptual integrity? First of all, concerning orthogonality, usually we cannot do a fixed separation between the various features that we expect from such a service. So we must pay extra attention to the issue of orthogonality, since we can find ourselves stepping on our own toes, fingers, when we do a change in one place. For example, let's say I now solved some issue with a new line of code. So several functionalities are involved here. I, of course, need to commit the code and send it back to the main repository. But I also have to close the issue that was opened for me in order to work on it. my work might change something that the documentation needs to be updated. And also even third parties should be informed of this change and want, for example, a continuous integration. So everything, there are many use cases in which many functionalities are involved, so this is a great risk for conceptual integration. Concerning propriety, here we are more calm because we are very targeted about software project management, but still we have to see that we're not doing some feature creep, adding special calculator, not special, but a calculator for adding hours, so of effort, let's say. So we need to think how to do it in a way that we're not incorporating like a general calculator, but only by related issues to software project management. Concerning generality, we would like the system to provide services to many kinds of projects. And actually we see it happening today with such services like GitHub, where it supports various languages, various models of development, of team organization, and even there are many non-software related projects that are managed over there, so we see that such a system usually is quite general, and we should keep it. As part of this work, we suggest some design patterns for doing this preservation. So just briefly, we can use a Django 4 style of patterns for preserving integration. For example, if we use a service builder, when we add a new provider, we make sure that the various parts are added in a consistent way that preserve conceptuality. For third-party integrations, of course, the adapter design patterns suits naturally, and we should use it in a way that does not break other parts of the system. So we are working on examining GitLab. GitLab became very popular in recent years. It's an open source platform similar to GitHub. Main difference is that the code itself is open source, so the model is free hosting for open source projects. It also provides private repositories, but if you want an advanced features, hosts or on-premise, you pay for those extra features. So we can examine various features of GitLab for their conceptual integrity issues. Concerning version control, generality is handled by GitLab offering various options, how to run it, how to access it, who can access it, much more fine-grained access control than other providers. So this gives the opportunity to many projects to participate. There are some issues of conceptual integrity. For example, there is a code snippets sharing service when you can paste some code from your environment and share it. And we asked the question, why is this code snippet not versioned? Let's say somebody suggests some improvement. Why not use also mechanism of pull requests to suggest improvements. So it will work exactly like a full Git repository is working. Concerning documentation, problem here are that many times several options can answer the same requirements. So, for example, some project document in a separate wiki system. Some are adding Markdown files to the source code. Some host the documentation in a web page-like environment. So GitLab provides all those features, and this can be cumbersome and confusing for some projects. Especially that the wiki is, in fact, a Git repository, but separate from the code. So let's say we do a change, and it also influences some document. So how do you do a link between those two changes if they are managed in separate histories? So this is an issue with GitLab documentation. Concerning the issue database, there are some features that you can automatically close issues in a commit message. So this is very nice, but we should see that orthogonality is not corrupted here. All the issue of APIs and third-party integrations is a big risk or challenge to preserve conceptual integrity while relying heavily on third-party offerings. So to conclude, Git was examined from conceptual integration point of view. We suggest moving further and discuss a broader service for software project management for its conceptual integration. We mark here that there are economic pressures like vendor competition that stress vendors to add more and more features, sometimes doing it quickly without taking notice of preserving the conceptual integration. So there are many issues to consider here, but we gave our angle here and the example of GitLab. Another contribution of this work is suggesting some patterns for dealing with this problem. And we think there is an area for continuous to do this work by examining other examples, by suggesting more patterns. And etc. You are invited to read the paper itself, which is available in the proceeding of the SEC conference. And I would like to thank you for listening, and we'll be very glad to get feedback about this work. Bye-bye.